With making setup for CCDIK, this should be done in the begin play. It's necessary to set the upper arm bone name and hand bone name parameters. It's also possible to set optionally the index finger bone name. Along with this parameter, it's necessary to specify how many bones there are in the index finger. In this example there are 2 bones there. The bone index _01 no longer refers to the finger. Optionally, it's possible to set sockets. They are needed for more precise positioning of the hand or finger. The performance parameter has a range from 0 to 1, where when equal to 1, it gives the maximum precision, the minimum performance. Soft transition is a parameter for smoother operation of the algorithm, which consumes very little performance. There are also additional settings for soft transition, soft factor, additional settings for prop sector. It will be discussed later. In general, this is a divider, so that the hand follows prop sector more quickly. The CCD algorithm has a reversion. This is when the calculation goes not from the finger to the shoulder, but vice versa. It can be turned on for both forward movement, hand to target, and reverse, hand from target. Motility data. This is a structure for changing the parameters of the mobility of the bones in the algorithm work. For example, you want that when moving a hand, the movement is achieved mostly through the forearm bone than the shoulder one. In this case you need to lower the mobility for the shoulder and vice versa for the forearm. Specific data. This structure is for additional settings of the algorithm. Set it as I showed in the video for now, we'll analyze it in more detail later. In addition to the left hand, it's also possible set the algorithm for any number of hands. Now call the setActorTarget function. In this function there are 2 delegates. For callback, the first is needed to understand when we have moved beyond the radius, the second signals the successful completion of the action. It's necessary to select actor towards which the hand will move. It's also possible to set an offset from this actor. If there is a tick in the actor is movable checkbox, then this means that the algorithm will be a tracking target. It's also possible to set an additional upper arm rotation, the time during which the hand reaches the target actor, as well as the parameters, the limits of the angles right and left, as well as the distances min and max. When moving beyond these clamps, the algorithm will be reset and the hand will return to its initial position. Let's study out the specific data more detailed. It's possible to set the length of the hand extension. Upper arm solver is a group of parameters for turning the shoulder when moving the hand. I have now such settings that when the left hand moves to the right, the shoulder will be rotated up to 680 degrees along the y-axis. Multi-negation is the coefficient of hand rotation, when the hand goes not just to the right, but also downward with respect to the shoulder. The next parameter moves the shoulder forward, if again the hand goes to the right. That is, this parameter is also tied on the upper arm solver. There's also a parameter for the intensity of such movement in the multi-negation. Now I have such settings that when the hand goes not just to the right, but also downward, the shoulder will be moved forward along the y-axis, that is, it will be 1.5 more forward. Now I will temporarily disable these rotation and movement parameters, and let's take a look at the result. It can be seen that without them, the hand begins to fail through the body. That's why firstly I'll set back the rotation. It can be seen that the shoulder begins to turn and the movement of the hand occurs in a better way. But there still is not enough of a small movement of the shoulder forward from the joint. Now it is even better, but of course these parameters can be readjusted in any way. Next there's the shoulder stretch. This is also a shoulder movement forward, but here it begins to stretch out only if the hand is straightened and reaches for the target. Don't set a too big value here, because a person's shoulder cannot straighten much. Divider is needed to align this stretching, when it's imposed upon the stretching through the parameter in the upper arm solver. It's also possible to adjust the rotation limit. I also want to note that if the tick in the actor is movable checkbox is turned off, this function essentially turns into the set world space target. The algorithm for a particular hand can be forcibly turned off by using the reset function. Also, the default is made so that if the character moves, the algorithm will be automatically reset, regardless of the values of the clamp. If you want to disable it, call a special function. If the tick in the actor is movable checkbox is disabled, as well as in the set world space target function, the hand will not be automatically reset at all, it could only be reset manually. Setting the additional upper arm rotation parameter may be useful to slightly change the path of the hand movement to the target. This can be useful when you need to get something from the top shelf, for example. There is a function to work with the component space. Also, if tracking is enabled, its parameters can be changed at any time. Check of the distance and angles can be implemented separately, using the appropriate functions. The function with the Z postfix measures the distance without considering the Z component. More details about them will be discussed later. Now I will tell you how to implement the press button. Let's start with the symbol option. In this function, there are a couple of additional parameters that adjust the pressing time, as well as the time for moving the hand backwards. Another very important parameter is position tolerance. It determines the tolerance and the position when the button is pressed. This parameter is needed because if the animation on the character is very active, it can interfere with precisely moving the hand to the desired position. The material of the button has one parameter, color. Let's create the dynamic material in the callback function so that when the button is pressed we could automatically change its color. This callback is called two times, once when the button is pressed, another when it is released. As you can see, the hand falls a little through the button. In order to prevent this, let's create a socket. It's also possible to set a small offset from the position of the actor, since the position always indicates the center of the object, and we need to touch the edge of the button. The offset parameter determines the exactly curvature of the finger turn. It's completely different than setting the socket. The parameter back offset is needed to straighten a finger. The value should depend on the length and initial curvature of the finger. Backbone index is parameter which determines to which bone exactly the finger is to be straightened, according to the score. 0 is used for the bone at the very tip of the finger, and the more this value is the closer it is to the shoulder. Let's now study out the more complex mechanics of pressing. Firstly, let's call the prepare function. This function is needed to move the hand, to prepare it for button presses. Now let's call the press button function. It will be the one that will press the button. The finger can be removed when the hand moves back after pressing the button. It's possible to use the prepare position that we set earlier, so that the hand is returned after each pressing exactly there. Otherwise, the hand will be returned towards the selected bone at the back move distance. The index here begins with the shoulder, that is, 0, the hand will be returned to the shoulder, 1, to the forearm, etc. Now I'll demonstrate how it's possible to implement pressing two buttons at once alternately. In this way it's possible to implement the mechanics of entering a code, in the device of which there is any number of buttons. I introduced an additional variable to save the button we exactly pressed. Don't forget to also introduce a separate variable that determines whether the button is pressed or released. Pressing the button can be implemented even for animals or a spider. The choice of bones in this case should be picked out for each case separately, because the spider has neither hands nor fingers. Now I'll demonstrate the work of the motility. As an example, I'll set the mobility in the hand bone at 0, and the movement in this joint will completely stop, but in others it will increase. Firstly, I'll also set up the right hand. The right hand moves to the left, so I will change the vector from x to x. We also need to change the shoulder rotation vector to the opposite. Let's call the start grab function. It will move your hand to the desired location. Note that I use index equals 1. This index corresponds to the right hand, don't confuse the indexes. Here it's also possible to customize special animation for the hand. This animation will work as if we called the blend bone before this function, with the bone name equals hand_r. Now let's select the target actor. We will have a sword. We also need to select a socket adjusted for a sword in the right hand. For the right hand, I will change the clamp values for angles. Align hand data is the structure using which it's possible to align the hand to the target. It's possible to adjust clamp for the alignment angle, as well as the number of additional iterations that are required to align the hand. Be careful with iterations, they affect performance. As you can see, the hand aligns well only on one side of the sword. In order to fix this, we can use the additional socket parameter. Firstly, we need to create the socket on the right hand. Let's copy transform data from the first socket. And now we need to rotate the sword 180 degrees with regard to the first socket. Now, from whatever side we approach the sword, everything is okay. Now we need to call the grabActor function and callback from event on completed. Let's create one more callback and call the reset function there. Don't forget to synchronize indexes, these are very important. Now I will show how this would look without align data. As you can see, using align is much better. The socket to which the sword will be attached can be changed. It's also possible to apply special animation for the hand when using grab action. Look, this is not even an animation, but just one frame, which can even be done manually using keyframes. Timer offset is needed to shift the grab actor moment a little. In the reset function, don't forget to also reset this hand animation, or then you can reset it manually. Don't forget to save the particular socket which the sword was attached to as a result, as we have two of them, because we used the additional socket parameter. It's time to study out the align to actor function. This function is needed to align the object that is in the character's hand with another actor. This function could be used for various kinds of actions, for example, when you have a key to a lock or a lever in your hands. As a hand socket name, it's possible to take any of the two sockets. It doesn't matter to which of them the sword is attached now, because it doesn't participate in the algorithm at all. It's also possible to make clamp by the corner. This parameter is identical to what we concerned a little earlier. Apparently I mixed up the hand, be careful too. Now I will create another align target. And I will demonstrate how else you can use this function. Using flip-flop, I will move the sword to one target, then to the second. It is very important to fine-tune the distance limits. and also much attention is paid to the orientation of the aligned targets themselves. Aligned targets are best done in hidden in-game. I will use a separate function to better adjust the character orientation before the target. I'll make the clamp angles in the function itself very large so that the filter is in the separate function that I created right now. As you can see, the function can provide data on how much to rotate the character to match the values entered by clamp. It's also possible to use a separate function for the filter by distance, and in the align actor function itself, to enter very large values. Add an additional socket for the sword on the body. In order to align the sword with the socket, there is a special function in which you need to specify scene component as well as socket name. In addition to this function, there is also a function that aligns objects with the scene component. To use it, we need to create a copy of the sword in the character itself. Props actor. First we need to create a socket on the hand. Let's add a specially prepared mesh as a preview asset. It is for both the left hand and the right. It's possible to choose any color. I'll copy orientation with hand bone. As a result, the orientation of the mesh should be chosen so that it coincides with the hand. Let's call a special function. It is very similar to the others that we have already considered, but it works only with props actor. Now let's create a special type variable to save the reference to the actor. As socket name we need to enter the socket that we've created a bit earlier. Now let's create a new blueprint for our future actor. As the action mesh component we can use any mesh here, but what is very important is the location of the pivot point in this mesh. For an example I'll show two static meshes, walls. One has its pivot point in the middle, the other, bottom left. If you want to implement door mechanics, then use the second one. Now we need to create a socket already in the static mesh of the selected wall. This socket is needed for the hand. It shows where the handle will be. Let's go to the class defaults in the target hand data array and add a new element. This array is responsible for the handle exactly. The more sockets are added to the mesh, the more elements there should be. The rest stays by default for now. Now let's add the component for the action mesh component itself. Select handle component from the list. For static mesh, select hand mesh, the same one that we chose for the socket. The color can be any. Do not mix up the left and the right one, it is very important. For parent socket, select the socket that we've created earlier for the wall. This component helps to make the correct align of the character's hand with regard to the handle. Do as I showed and click on the Save Handle Type. If this is not done, then the values won't be saved. Thus, it's possible to adjust different handle type. We will talk about this a little later. Let's go back to class defaults and set the start position. I've just set it to the 0 position. Highlight the action mesh and shift and rotate to the desired position. And now click on Set Tar Position. This will set the data to the current position of the action mesh. Now by clicking on Set to Start Pos, let's return the mesh to Start Pos. Further clicking on Move to Start Pos and Move to Final Pos, it's possible to see how our actor will work. Let's save and place it on the stage and see how it works. As you can see, it works a little different from what we wanted. This is due to the fact that we open the door too far and the hand does not reach it. Let's reduce the hand move limit alpha parameter a little. This will reduce the hand movement behind the actor. Let's now study out the movement parameters in more detail. Let's start with blend time. It just determines how many seconds the actor should be brought from the initial position to the final. Hand move limit alpha. We've already considered a little earlier what percentage of the entire actor's movement the hand should follow it. The next parameter is also only for reverse mode. In short, when the actor goes in the opposite direction, We close the door. Interpolation type is type of interpolation when moving. It's possible to select any graph. For example, with exponent 5 the actor moves slowly from the beginning, and then makes a fast movement. This is a very cool S-shaped curve. It's also possible to set it up in such a way so that the character does not remove his hand after movement. In this case it's possible to reset it later with a special function. Interrupt behavior determines how the actor should behave if the movement was interrupted. It can return, end the movement, stay in the place where it was interrupted, or even leave the presetting, in order to change direction where to move from the second attempt. Turn off the collision against the wall so that the character does not twitch so. There are also settings for interrupt during door closure. Tracking type determines the behavior of the hand while following the actor. We can leave the standard behavior, make the character reset his hands only if it moves itself, or even make the hand follow in any case. There are also scale parameters for movement. They scale all the movement settings. This is mainly used in runtime. Now let's study out the target hand data array in more detail. With turning on align enabled, the alignment of the hand is enabled according to our created handle. Let's now set up the forward final. This is the position which the hand should reach at the end of the movement outside the door. It is not used by default. Settings for reverse are the same align settings for the hand, but when we close the door, do not forget to tick use handle type, and also save using save handle type. The next parameter allows distributing the settings of this socket to other sockets. In this case not only the settings are saved, but also the handle type. This is necessary when we have many sockets on our door with which we can react, and in order not to duplicate the settings for each of them, this option exists. For all other elements, just fill in the target socket name parameter, the rest stays by default and they will copy the behavior of the first one. Now the hand will react with the nearest socket. This way it's possible to create any number of sockets. When to uncheck this box, then it's possible to make a unique setting for each socket, as well as to create own handle component. Parent socket in this case has to match the second socket. I made a little mistake on the video. Don't forget to tick the align enabled for the second socket. Now let's consider a slightly different mesh, an item like a lid of a chest or other box. There are created 3 sockets for handle. As you can see, the first socket here is the main one here. turn off the collision of the item. As you can see, the handle component has all types disabled, except for the forward start. However, the hand will rotate. This rotation is due to the fact that the mesh itself rotates, and is followed by the handle, which was repositioned in the initial position. Exactly this rotation controls the rotation power, and if this parameter is set to a value close to 0, the hand stops rotating completely. We'll talk a bit later about complex angle calculation. The auto-calculate angle parameter is needed to change the angle of the hand in a specific way, depending on the relative position of the hand and handle. By default, the hand can bend strongly when approaching from an unsuccessful angle, because it tries to take a handle orientation. If to set this parameter to only yaw, then now the yaw component of the angle will be automatically adjusted. For moving back there's its own parameter, do not forget about it. The only initial parameter is needed in order to calculate the angle only at the moment of the start of movement, otherwise each frame will be calculated. The following mode allows adjusting the yaw component automatically, but at the same time retains the initial yaw component of the angle. Keep in mind that for the correct operation of this mode, it is necessary that the handle component remains at the 0 position or is shifted only along the forward vector of the mesh. In our case, the handle can only be shifted along the x-axis. Don't forget to click on Save Handle Type after the completion of the transformation. The last mode makes adjustments to all components of the angle, but not for yaw. Keypinit yaw is best for chest and various boxes, but it has its own adjustment nuances. Don't forget that in this mode shifting the handle is only possible along the forward vector. The handle is Let's consider such an object. As you can see, 2 sockets and 2 handle are created on it, but here they are already designed for the left and the right hand separately. This item works as a valve. Note that the meshes for handle are also different, for the left and for the right hand separately. There's tick in align enabled checkbox, and there's also set the angle mode to only yaw. In the character's blueprint, we need to call a special function that works with 2 hands. Here we need to fill out the structure with data for each of the hands. Note that we need to strictly specify the target socket here. In the version of the function for one hand, this socket was selected automatically. As you can see, the orientation of the hand is not correct. This is due to the fact that there's a very steep angle, and also due to the fact that we turn the valve and our hands turn with it to a completely different position. Of course, we can change the mode for auto-calculate angle. But the best way to solve this problem is to use complex calculate. In this case, the angle will be calculated using a slightly different algorithm, but keep in mind this will slightly affect the performance. The border parameter is needed here to determine at what angle of the hand with regard to the up vector, the complex calculation method is to be used. For a better line of hands for objects of this type, I would also recommend setting up reverse start and possibly even reverse final for the handle component. Use complex calculate works only in conjunction with only yaw and only yaw. Keep in at yaw angle and with only How to use multiple target points. Firstly, click on Set to Start Pause. If this is not done, an interface bug may come out and the mesh stops moving. In this case, Manually set its position in Start Local Position, then close the tab and open it again. Select the mesh and set it to the desired position and orientation. Next, click on Set Add Target Position to save the data. Now, in order to choose which position target should be moved to, we need to use the final position index, where one and the next will be additional target positions. Next I'll show how to use the function to change the final position index in runtime. Now let's talk about how to insert transition points. Firstly, click on Set to Start Pause. Add a point, select Mesh and move it to the desired position. Next, click on Set Position, set the transition point. In addition, it's important to specify in which position it will be located. Here 0 means position at the beginning, 1, closer to the end. Thus, it's possible to set any number of transition points. Offset on the y-axis is too big, let's reduce it a bit. Transition points are applied to all endpoints. We will consider how to change this a bit later. Let's now add an additional set of transition points. Let's set the position manually. Now we can choose which set of transition points is to be used. In runtime, this can also be changed by calling the corresponding function. But just keep in mind that you can only call this function if you are at the start or end point. There's also possibility to immediately jump from any current position to the end point. To do this, use the following chain of function calls. As you can see, I immediately jumped from 0 endpoint to 1, bypassing all the transition and start points. Now I'll show how to use several different handle component for one socket. To do this, let's create a new handle component, assign it as the socket that is already used for the other handle component. Go to the Tags menu and create one tag with an arbitrary name. Do the same for the first handle component, just give it a different name. Use a special function to determine which handle component exactly is to be used by the name of the tag. For props actor it's possible can set the initial position. If one of the transition points is chosen as the initial point, then it can be determined in which direction the movement will proceed further, i.e. if for example this is a door, we can further close it or open it. It's also possible to set the target position. It's even possible to set a transition point as a target. It is even possible to set target alpha, and the position and orientation will be determined by interpolation. This way the steering wheel can be implemented. But note that the last functions shown are still experimental. Now I'll show how to implement the mechanics of grab objects using this class. Using the example of a sword. Create one socket at 0 or near 0 position. Provide the settings that I showed. It's very important to uncheck the reset hands. Let's also create handle component. Do not mix up the hands. The hand should be the one that will make the grab. Set the desired position and orientation for the handle. Don't forget to save the result using the Save Handle type. It's also very important to set the blend time to a value close to 0. Now let's create a socket for the right hand, by analogy as we did for the left. This time, use the static mesh as the preview mesh for the right hand. The callback for this function contains many parameters of the bool type. We need to track when the end action parameter becomes true. This will signal that the movement for the target is finished. Next, we need to reset our prop sector, because we use this function not for its intended purpose. Next, we need to call a special function for the correct setting of offset from the hand to the actor. And the last point is to call those functions that we studied out in the part about the function keyGrabActor. with one slight difference. The last time the name of the socket to which the sword should have been attached was taken from the start grab actor function. This time we need to enter it manually. As you can see, I forgot to change the hand index to value as 1, because we use the right hand. This method allows adjusting a line of the hand to the sword as needed. Let's now analyze the situation when the subject is too low, with regard to the hand. There are two ways to solve it. Firstly, it's possible to use the function from the group play animation, any of the list. To do this, it's necessary to have a suitable squat or tilt animation for the character. It's obligatory to make delay to give the animation time to play. And at the end of the whole action, call the release animation stack to exit this animation. In this case, I'd also recommend checking all clamps before calling the action functions. The second way is to use functions like lookAtActor. In this case, don't forget to tick the Calculate Once checkbox, otherwise when taking hands back to the initial position, the character will continue to turn towards the sword. If you use the lookAtActor function, reduce the value of the shoulder stretch parameter to almost 0, otherwise a bug may appear. In addition to moving and orienting, it's also possible to change the scale of objects, so that it's possible to make the illusion of growing or reducing objects. Now, I will briefly show how to properly prepare the mesh for use in props actor. For example, you have a unified mesh, chest. Firstly, do the export in FBX format. Open Blender and there you need to do import first. Create another window on the left by dragging the triangle with the mouse and make it UV. Select the chest and go to Edit Mode. Deselect by pressing A. Select the bottom edge of the chest lid and move the cursor to this position. Go back to Edit Mode and move Origin to the cursor position, then reset the object position. Press Shift+A and make Apply Location. Go back to Edit Mode, select Face Select, and also press Z. Next, press B and make a rectangular selection. Go to the second window and click Keep UV and Edit Mode. There, this will show those places in the mesh that are highlighted on the UV map. And then, using both windows, try to leave only the chest lid in the selection area. It's very simple to check, just pull the selection up, only the lid should be moved. Ctrl+Z will return the test movement up. Don't forget to use the UV map. Circle selection is very useful there. Use the C key for this. To deselect, hold the Shift key. The result should be like this, then press P key, and select the first item. Go back to the object mode and select the lid from the beginning, then export the base of the chest. I forgot to tick the Selected Objects checkbox. Next, just make import back to Unreal Engine. As you can see, the material is preserved. This is all because we did not change the UV map. Next, make the lid of the chest an active mesh. Add another mesh and make it the base. And now everything works great. Known issue. 1. You forgot to click on Set to Start Pause and began to change the orientation of the mesh from its current position. As you can see, the unsynchronization occurred. 2. You forgot to click on Save Handle Type after changing the position of handle component. 3. You changed the position or orientation values of the handle component directly. This will not work. Change either through Gizmo or through the Transform panel. 4. For some reason mesh stopped working. What needs to be done? Click Set to Start Pause, then copy the data from Start Local Transform, and paste in Transform of Action Mesh. Save, close the tab and open again.